All right, so 5.5. So we're going to get more log. You'll be stronger at logs because of this, which is nice. We have, a little bit of logs on our exam Thursday. We'll go deeper here, so those will be easy for you after we've done all this deeper stuff. So what do you think about that one? What is the log base 3 of 3 to the 82 power?
Well, let's find out.
It is 82. Yeah. Remember what we've learned about logs, bases? When the base of the log and the base of the power match, you can just cancel those out, huh? And it's just 82. Is that good? Remember that? When the base of the log and the base of the power match, you can just cancel those out. Like that. How about I show you 2 other ways to make that, I hope, really comfortable for you. Let me rewrite it and say it a couple other ways. One way is you could just put an X on the left side, right? You could just say, I'm gonna go X over here, and I just got to find out what X is. And then you could, and remember how we get rid of a log? You do like 3 on both sides, and it cancels that out. Remember that? So then you'd have 3 to the 82 is 3 to the x. So what does x have to be? 82. There's another way to see that the answer is clearly 82. How about one more? Remember what I said you could verbally say a log is? Log. What is log? How you can say it? Power needed, yeah. So think with me. Power needed on a 3, that's the base, right? Power needed on a 3 to become 3 to the 82. Power needed on a 3 to become 3 to the 82. 82. I mean, it's just obvious when you say it that way, huh?
By clear observation.
By clear verbalization, yeah. Right, we good there? Is that making sense? I'm just showing you all different ways. But the simplest way is just to say, hey, when the base of the log and the base of the power match, they just cancel for all those other reasons we just went over. Okay. Okay, so what do you think about that one?
23.
Yeah, because what's hidden, invisible there is a little base E, huh? Natural log always has a hidden, lowered down base of E. That's in addition to the blue E that's already there, huh? Because that blue E is on the level. He's not the base. He's on the same level with the L, and he's not down low like a base. So there's another invisible E there, huh? And so, yeah, when the base of the log and the base of the power match, they just cancel. That's just 23. Same exact rule. And then number 3, it's going to be the same thing. 3 to the log base 3 is 6. 3 to the log base 3 of 6. So what happens there?
I would think 3 to log base 3 cancel.
These cancel. Answer's just 6. Again, when the base of the power and the base of the log match, they just cancel. If you want to go through the saying thing, this one's nice for that. Let me just take the power up here for a minute. Let's think, what is the verbalization for this? How do you say this? Log, you read power needed. Power needed. So what all of this is the power needed on a 3, the power a 3 needs to become 6. So whatever this equals, it's the power that 3 needs to have on it to become 6. So if you put it on 3,
that's 9.
It'll become 6. Because it's the power 3 needs to become 6. Let me say that again. What if I checked with Doug and I said, Doug, how much change you got in your pocket? And he told me secretly, whispered in my ear so you all don't know. And I said, okay, based upon what I know, Doug needs 30 cents more to have exactly $1 in his pocket. I'm going to give Doug 30 cents. So how much does he have in his pocket? $1. I mean, once I give him the 30 cents. Once I give him the 30 cents, right? If I say he needs 30 cents to then have $1, I give him the 30 cents. What has he got? He's got $1. Well, that's what this log is saying. This log is saying, I'm the power needed on a 3 to become 6. I'm just what the 3 needs. I'm just what he needs. I'm the power needed on a 3 to become 6. So if you put it on a 3, it'll become 6. That's another way to say it. Is that making sense? Or is it getting more confusing when I say it other different ways? So that's what a log is, the power needed. Or the easiest way is these guys just cancel, don't they? When the base of the log and the base of the power match, they cancel. They're going to say, we're going to go the other way. Instead of taking one log, like look back at the last problem, right here. The last problem, in the last 5 or 10 problems, we take one log and make it several logs. Now we're going to take 2 logs, and they're going to say, write as 1 log. So they want us to take the 2 logs and make it 1 log. So we're going the other way now. Make 2 logs into 1 log. So we're running the properties, well, I guess maybe it's forward, whatever you want to call it. It's the other way. So how do we do it? I bet you can do this one pretty easily. Make those 2 logs, combine them into 1 log. So yeah, what do you do with that 7?
7, go back to forward.
Yeah, exactly. Abdul. And the 6.
Log base 5 equals 7 times 3 to 6.
Yep. And then just put them, they're the same base, aren't they? They're both log base 5. Just crunch them into 1. Adding, an easy job for 2 people, becomes a harder job, multiply, for 1 person. 1 log. Now, technically, you probably should put parentheses around that so you know that all of it is the plug-in to the log. I think MathXL will take it okay without that. But just to be extra careful, you could do that. Make sense on that? That okay? Going the other way, getting the hang of back and forth, how we're doing this? It's all about the easier operations, plus and minus, for 2 logs, harder multiply, divide for 1 log. Okay, so it's 15. 16 is similar. Log base 6 of root x minus log base 6 of x to the 6. So 16. Log base 6 of root x minus log base 6 of x to the 6th. Is that right? Yeah. Okay, same thing. 1 log, no powers. Right, it's 1 log, no powers. So this was a little more tricky to get the no powers thing. See what you can do there. So 1 log, so we have root x over x to the 6th. Good so far? Right? Subtracting, easy job for 2 people, becomes a harder job dividing for 1 log. Harder operation for 1 log. Good to there? Now the question is, how do we clean up that like root x over x to the 6th?
1/6.
What is the root?
1/10.
It's a half power, huh? Yeah, so this is equal to log base 6. This is a half power over a 6 power. Good to there. Half power over 6 power. Now, what are we going to do with those powers? Remember the rules for powers?
Same denominator, or, yeah, same base, you can subtract them, right?
Yeah, same base, subtract powers. Remember that? Remember like x to the 5th over x to the 3rd is x squared. You can subtract powers, top minus bottom. And what if the bottom's the bigger one? What if you had like 3 3 up here and 5 down there.
-2.
It'd be -2 because, again, it's always top minus bottom. 3 minus 5, -2. Remember those rules? Right? Dividing, you subtract the powers. So that's what we have to do. So we have to take a half minus 6. So this will be log base 6, a single x now, making it 1x of a half minus 6. Well, how do we do? In fact, I'm probably going to run out of room here. Let me bring it over. And then I got to subtract a half minus 6. So I get log base 6. Oops, I forget to half minus 6. Okay, so how do I subtract a half take away 6? You know how to do that. Common denominator, right? Put it over 1. Top and bottom by 2. So that's log base 6 of x to the 1/2 minus 12 halves minus 11 halves. We good with that? It's just 1/2 minus 12 halves. And then grab that power, bring it down to the front, minus 11 halves, log base 6 of x. Right, because powers can come to the front. So that we did it, we made it no powers. We brought the power down to the front. Questions on that one? Are we good? All right. Okay. So same kind of thing. They want us to what? Make it 1 log. So yeah. So make it 1 log. So give that a try. See if you can combine those into 1 log. I bet you can do that one.
X minus 6x plus 6.
Good job. You got to factor that, huh? That's going to factor x plus 6x minus 6. We good? That's right. And then you know where that 4 is going to go that's in front of that second log.
Well, the x plus 6 is cancels, doesn't it?
Mm-hmm. That 4 is going to go to the power. And then make it a big old fraction, right? Because it's subtraction.
I like it. Makes sense.
You cross them out.
Yeah. Yeah. Okay, let me write it. And you're exactly right. That 4 comes up here to the power. So it'd be x plus 6. So everybody see why it's why is it a fraction?
Because of subtraction.
Because of subtraction, right? Remember, subtraction goes with division,
Subtract.
right? On property number 2 over there. Subtraction and division go together. They both make things smaller. So if that was adding, they'd be multiplied, huh? Right? On that? So yeah, now you just factor that top and cancel. Exactly right. So that'll be log base 4. That's going to be x plus 6, x minus 6 over x plus 6 to the 4th. And then this cancels, leaving 3 here. So the final answer then, log base 4 of x minus 6 over x plus 6 to the 3rd power.
And we don't have to get rid of the power because it's not asking for that.
Yeah, you can see why they this is the one time, look back at their words. They just said single log, nothing about the power this time. See, next time they'll talk about the powers again. You know, why'd they leave it out? Well, because there's no way you could. Because they don't both have that power, so I can't bring it to the front. So it's stuck there. That's why they didn't say that. They know what they're doing on that. Yes?
Oh, you can't. Okay.
Yeah, I can't bring that 3 to the front. Okay, now, if he was on everybody, like if somehow, you know, he was like up here, like everybody's power, then I'd totally bring him to the front. Then he could be everybody's multiplier. Makes sense how the rule works? You've got to be everybody's power to go to the front and be the multiplier for the whole log, everybody's multiplier, right? He's only the power for one of the parts, so he can't become the multiplier for the whole thing. So he just stays put. And they didn't say anything about getting rid of the powers for that very reason of this problem. All right. Number 18 is a little messy. We're getting close. That's close to the worst of it. ln of x over x minus 7. 18. ln of x over x minus 7. Plus ln of x plus 7 over x. Minus ln of x squared minus 49. Okay, so we want to combine all those into one natural log.
So one's gonna be times times and one's gonna be divided.
Yeah, right,
But you're
right.
gonna have to factor the last one.
So the first two, so we'll do a single ln, put all of that in one natural log. So you know, adding, subtracting, easy job for several logs, just adding and subtracting. Lots of people working on the job, it's easy, it's just adding, subtracting. But if one person has to do the whole job, it's harder, multiplying, dividing. So what's it going to be? X over x minus 7 times x plus 7 over x. Now, y'all with me to here? I wanted to show you because the last part could be a little tricky. What am I going to do with this x squared minus 4? It says minus. Minus means
Division.
divide. So am I supposed to like go divide?
No.
Like that? You could. I mean, that's true. That's not wrong. It's just hard. It's hard to do it. That's right. That's actually okay. That's just hard to do it. There's an easier way I could do divide than doing the big old bar like that. Dividing is just
Multiplying by the bottom.
just 1 over, huh?
5%.
Just put it right there. Yeah. Everybody see what I'm saying? That'll work too, and that's easier.
Okay, but one of the x plus 7's cancel.
Yeah, we're going to factor and do some canceling. Yeah, we have a little more to do. But is everybody good with that? So I want to make sure you're clear on that. So dividing means it goes to the denominator, huh?
It's so exciting.
Like that? And then, yeah, now we're going to factor and cancel.
I have a thing with everything. I get very excited with it.
So ln x over x minus 7, x plus 7 over x,
Oh, don't say that.
1 over x plus 7, x minus 7.
He's teaching calculus, yes.
Okay, so now,
I just found that out recently.
what can we cancel?
X plus 7.
X cancel.
X plus 7, and these x's, huh?
Go away.
Yeah. Is that good? Just making some, am I racing ahead of you? Is this making sense there? So again, the subtraction log becomes divided, denominator. Denominator is dividing. Whenever you stick something in the denominator, you're dividing it. That's really what you're doing. And I factor, cross cancel, and now where are we at?
1 over x minus 7 squared.
Yeah, ln of 1 over x minus 7 squared, like that, huh?
So 1 over 2 ln.
Now, we can't leave it that way. They did say on this one, no powers. We're going to look back.
So it's
It
minus
says
2 times
no powers.
Because it's a negative exponent.
Good job. Yeah, so what are we gonna do about the power things? They are gonna say, let me get rid of, you don't need these extra parentheses here. They are saying no power, so we gotta do something about that too. But you can't just move it out front right now. Not when it's like part of a fraction like that. You have to first, remember the rule? This is x minus 7 to the minus 2, isn't it? Remember, negative powers jump things to the bottom?
The fractionator.
So it just jumps it to the bottom like that. The negative power does that. So, so you have to write it that way, and then the negative 2 goes to the front. And you get negative 2 ln x minus 7.
So can you write it the different way, like 1 over x minus 7, 2? So 2 go by 1, 2, because 1 power 2 is 1, so it's not going to be changed.
What do you want to do, Abdul? So the 3 log properties, which you have on the sideboard as well, but in case you can't see that very clearly. So log base b of x plus log base b of y is log base b of x times y. Number 2, log base b of x minus log base b of y is log base b of x over y. And number 3, log base b of x, this one's a little different, to the power p, that power can come down in the front, power times log base b of x. Okay, let's talk about those properties. This whole section is about those 3 properties. Really, everything else we do for the next like hour and a half or hour and 15 minutes, and we'll do like the last maybe 15 minutes on the next section. The rest of this section is all about those 3 properties, just forwards and backwards and using those properties all different ways. So we want to get those really, really comfortable. Of course, you just, for exam, this will be on exam 3. You'll put them on your card, but the more they're deep in your mind, the easier and quicker you'll use them. So let me help you to put them deep in your mind. First thing to notice is that, think about when, what was the first math operation you ever did when you were a kid? Adding, huh? Yeah. You start with adding. Then you subtracted. Then you got a little older, and you did multiplying and dividing. Huh? That's like a higher level. I still remember being scared. 4th grade is when they do it younger now, I think. 4th grade, had to go up front to Mrs. Unmack's desk and tell her your times tables. So I remember that being scary. So that got a little higher, and then higher up, there's like powers, like 2 to the 3rd and powers, right? So think about the math operations in that hierarchy. They do exist in that hierarchy. And we also see that hierarchy with the order of what's the order of operations? Remember that? The PEMDAS, please excuse me, dear and Sally. So the parentheses are, above it all. But then exponents, that's like powers, right? M and D, multiplying, dividing. And Sally, adding, subtracting. So that's what the order of operations is reflecting, is this same hierarchy. And logs are interacting with that hierarchy by bringing things down one level. What do I mean? Multiplying right here is connected with adding. See, multiplying goes down to adding. And dividing right here is connected with subtraction. Dividing comes down to subtraction.
Wouldn't
Like that.
So you're adding, so don't you go to multiplication? So like number 1.
I'm kind of looking at it backwards. But yeah, we're going to go back and forth. So I'm just saying they're connected. Whichever, we're going to go both ways. Yeah, they are definitely connected. And then this one, power, becomes times. See, power comes down to times. So see how the logs are involved with bringing things down a level or up a level, depending which way you look at it. Right? Why do they do that? Well, because remember, they're reverse powers. So they have to do with, reversing the effect of powers. So, and then let me throw in one more thing to help you remember it. That would be the old saying, many hands make the job lighter. I don't know if you know these. I'm an old guy, so I know old sayings. But, and that just makes sense, right? More people working on a job makes it easier. Right? Yes, sometimes I can wreck things, huh? I remember a few months ago, I came home and told my kids, I lifted a 700-pound table today. And really, me and like 5 other guys were helping somebody move. All together lifted a 700-pound table. So the idea is lots of people should make the job, they get along well, should make the job easier. So that's what's happening with the logs. What I mean is, see how with 2 logs, it's just adding, easy operation, low level. For 1 log, it's the harder operation, the times. See how that relationship exists? Same thing here. 2 logs, it's easy, it's just subtraction, that's easy. Did that again? That's harder, 1 log, dividing harder. So it's the harder operation for 1 person, 1 log. It's the easier for the 2. That's how the thing works. Okay, so with that, let's dive in and do a million problems all about those properties.
A million?
Well, maybe 28 problems of 2. They want me to figure that out without my calculator. Figure out a nice clean number there.
12.
So what can we do with the properties? Thinking about those 3 properties which are on the sideboard. And now notice these are the same base. Now let's go back to the properties real quick. Did you notice that in all the properties the base never changes? right? Log base B, 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 log base B. They're all log base B, aren't they? So these properties are for use when you're not changing the base. So we're not changing the base at all, keeping the base the same. So that fits here. Number 4, same base. They're both log base 12. So it's going to be log base 12. And then what can I do with the 6 and the 2? We're talking about adding for 2 logs. Easy job for 2 people. Adding, just a simple job, right? For 2 logs. For 1 log, it's going to become multiplying. A harder job, right? Multiplying is higher level than adding. And so then that is just log base 12 of 12.
Just one.
Do you know that's just 1? Exactly. Is that good? Why is that just 1? Well, because log is what word? How do you verbalize log?
Power needed.
Power needed on into, like, what power does a 12 need to become 12? Power needed on a 12 to be 12. Well, 1. It's like a silly question when you put it that way. Right? So that's just 1, and we did it without any calculator at all. All right, let's try number 5. Log base 6 of 36 minus log base 6 of 6. So number 5, log base 6 of 36 minus log base 6 of 6. So we want to subtract those two.
Why?
Yeah, same.
Yeah. So yeah, if you could just read the power needed, you can just nail it out. Yeah, there's a couple ways you can do this problem. You could just read it. You could just say power needed on a 6 to be 36. What's that going to be? What's the power needed on a 6 to become 36? 2, huh? So that first one's just 2. And power needed on a 6 to become 6? 1. The answer is just 1, isn't it? Now, let me also do the property, because we'll have to in a minute. So you could also do the property and say, look, they're the same base, both log base 6. So subtraction, an easy operation for 2 people, easy job for 2 people, just subtraction, becomes what for 1 person? Division. Are you seeing how subtraction is connected with division, whereas adding is connected with multiplication? Why? Because subtraction and division both take away things, make them smaller, don't they? When you divide numbers, they get smaller. When you subtract, they get smaller. Versus adding and multiplying both make things bigger. So they go together. So yeah, so we could do this, and then this is log base 6. What is 36 divided by 6? 6, and then you know that's 1. So either way you want to solve it, it's going to be 1, isn't it? All right, let's keep going. Number 6, log base 2 of 3 times log base 3 of 4. Okay, number 6. Log base 2 of 3 times log base 3 of 4. So we're multiplying a couple of logs there. How do we do that? Let me ask, is this one of those 3 properties? Right. How do you know it's not right away?
The base is same.
Bases are different, huh? See how this one's a log base 2 and that one's a log base 3? So different bases, that's not one of those 3 properties. All those 3 properties are same base. So we got to do something different. It's not one of those 3. Well, then what in the world is it? It's the special one. I also wrote down there at the bottom the special one. Let me remind you. We did it last week. I call it the special, but it's change of base is its official name. It's the change of base formula. And that is, whenever you have the log with some base of anything, call it A, you can put the top one on the top and the bottom one on the bottom, making it into 2 logs that are really base 10. Let me pause for a minute. Do you see that rule? You remember that from last week? Because what we came up with that last week because we only have on our calculator. What logs can you do on your calculator? Yeah, most calculators can only do log base 10 or log base E, natural log, right? And so how do you do other, like what if somebody asked you, please do log base 2 or 3 on the calculator and tell me the answer? How are you going to do that? You don't have a log base 2 button. You just have log base 10, and you have log base E called natural log. So how do you do other weird bases? You turn them into 2 logs. That was this special rule we learned, right? You just let the top, one that's on the top, the one that's higher up, go on the top. The base that's lower down, let him go to the bottom. make it 2 logs. See, both these logs have invisible understood 10s, don't they? They're both log bases of 10. That's why they call it change of base. We changed it from a base of b to bases of 10, 2 logs of base 10. So anyway, that's what we do on this problem also. We just say, okay, look, this first thing, we can just make that log 3 over log 2. Right, the top goes top, the bottom goes bottom. And the second one, we can just make that log 4 over log 3. The top goes top, the bottom goes bottom. Now it's just 2 fractions multiply. What can I do with those 2 fractions? Cross cancel, huh? Yeah. So, let me get this out of the way here. So, bring down what we have. And what do we have? We have log 4 over log 2. What can we do with that?
Reduce.
Well, yeah, you might think you can just cancel the logs and stuff. You can't just cancel the logs because that's not multiplication, right? That's not log times 4 and log times 2. It's log of 4. It's like a function. That 4 is plugged into the log function. That 2 is plugged in to the log function. It's not multiplication. So it's not simple like that. You know what I mean? You can't just cancel. But it turns out the answer will be, if you're thinking, isn't the answer just 2? You're right. It's for a little bit different reason, though. We can, how can I write that 4? 2 squared, so it matches with the other 2. 4 is 2 squared, right? And then, what does property 3 say that you can do with powers? Yeah, that will just come down to the front, huh? 2, and then it'll work. 2 times log 2 over log 2. And then we can totally cancel them. So yes, indeed, the answer in the end is just 2. Did you track with that last couple little steps there?
So you're not gonna do like that, log 4 minus 2, just log 2.
Oh, that's a coincidence. That's not right. Good question. So yeah, please ask those questions. Yeah, Abdul has a really good question. He's saying, well, yeah, I see what you did, Mr. Aaron, but couldn't we also just, or you meant 4 minus 2, huh?
Mm-hmm.
4 minus 2.
Yeah, 4 minus 2. Can't we just do that? And then that's just,
It's gonna give me log 2.
that'd be log 2 instead of 2.
Yeah.
Yeah.
So is the answer, yeah. So that's not right, but it sure looks right. Remember the saying I said about easier job for lots of people, harder job for one person, right? So think about, notice how that does not fit what we just did there. This is dividing for 2 logs, so that's a harder job. Dividing, remember, multiplying and dividing were the harder, adding, subtracting were the easier. That's a harder job for 2 logs, 2 people, becomes easier. Subtraction for 1? No, that's the properties done backwards. Right, see the properties? It's if the 2 logs are added or subtracted, 2 logs, and the 1 log is multiplied and divided. Right, it's the harder operation for the 1 log. It's the easier for the 2. That's how the properties work. That's why I made that saying up, to help you not make that mistake. Getting the hang of it, does that make sense? You can't say dividing for 2 logs, that's the harder job, would become easier for 1 person. That wouldn't make sense, right? It was hard for 4 people to lift it, but 1 person, no problem. That's not how things work. So good question. Does that make sense? Exactly what I want to help clarify. Is that good? So that's all not true, huh? Good on that? All's well? All right. Moving forward in calculus. Let's see what we got. 9 to the log base 9 of 7. Minus log base 9 of 3. Okay, yeah. So we have the 9 as the base, and those 2 logs are up there in the power of that 9.
Don't the log base 9s cancel if they have a
Yeah.
base of 9?
And so we would think, well, just go in there and just cancel. So, can't you just like go, cancel,
No,
7 minus 3
because the minus sign.
equals 4. Yeah, that's actually wrong, but it sure almost looks right, because haven't we learned, so don't write that down, I'm doing lots of wrong things today, so I'll warn you when I'm doing something wrong. That's wrong. I'm going to do it right and say that's close, though. That's not far off the mark. That's pretty close. There's just one small mistake with that, because the thinking is 99% right. That is bases, when the base the base of the log, the base of the power match, you should be able to cancel them. You should, that's true. Except it's only 1 for 1. You can't let one base of a power cancel 2 bases of logs. That's not what it is. You got to get that, and so instead, that's not true, but it's close to true. Instead, to make it true, to fix it, you've got to make both these logs become 1 log. So leave that 9 as there. How can I make these 2 become a single log if then I could cancel it? So what do the properties say? Subtraction, an easy job for 2 people. Same base, they're both the same base on log 9, becomes a harder job for 1 person, what? 7/3, division. Now I can cancel them. So this is all wrong. Now I can cancel them. The answer is actually 7/3 rather than 7 minus 3. And that's our answer, and we're done. Did that make sense? Do you see how we use the property up there? Subtraction, an easy job for 2 people, becomes division, a harder job for 1 person when you combine them. And then it's just 1 for 1. 1 base cancels 1 base of a log. Good? These rules. All right, let's try number 8 here. Log base 2 of 8x. So, great, log base 2 of 8x. So how am I going to do log base 2 of 8? Oh, what do they want me to do? They want me to write a sum or difference. Okay, they're saying write as a sum or difference of several logs. So I wanted to go from 1 log. So we're basically, now what we're going to do is we're going to run these properties backwards. We're going to go from the right side to the left side, from the 1 log back to the 2 logs. If you look back at the properties, wherever they are here, we're going to go from 1 log back to 2 now.
This reminds me of like cosine A plus cosine B.
Kind of like that, huh?
That's what I was
Yeah,
thinking too.
that's true. It is very similar. So how do I go from this 1 log back to 2? I'm going to use the properties. Multiplication, that's what's really between the 8 and the x, huh? Multiplication, harder, that's multiplying and dividing are considered the harder operations, adding, subtracting, the easier. Harder operation, multiplication for 1 log, becomes easier just adding for 2, and we're done. That's all they want. Does that make sense on that? Multiplying becomes adding. Harder operation for 1 log, multiplying, is easier. It's just adding for 2. All is well. Recap, we want to talk about it more? Let's go forward. Okay, so what it's going to say is write with no powers. It wants me to get rid of the powers. So which log property am I going to use? The third one, that says powers can come down to the front. So you grab that power, bring it down to the front. Done. All right, let's go on to number 10. Things will get a little more complex. Natural log x squared root of 6 minus x. Natural log x squared root of 6 minus x. And they're going to say, write as several logs with no power. So they want me to take this 1 natural log and make it into several logs. Well, 2 logs with no powers. So basically I'm going to use the log properties. Again, we're using them backwards. We're going from right to left. So natural log is, you know what that is. That's just log base e, isn't it? So there's nothing special. Natural log is just another log. All the same rules will work. So what's it going to be? Can you see what's going to happen here? It's x squared multiplied by the root, huh? Those are times. So multiplying, dividing, that's what I'm calling the harder operation. Multiplying, harder job for 1 log, multiplying, becomes easier for 2, becomes adding for 2. Good so far?
So now the power comes down in front.
Good. So then the power comes down to the front, the 2 power come down to the front. We'll have 2 ln x plus, now the other part's what I want to talk to you about. So we good to there so far? You all good? So just multiplying, harder operation for 1 person, easier job for 2 people, just adding. Now, they're not going to let me leave that root like that. If I type that in, it won't be happy. Why not? A root, anybody remember? A root is a certain kind of a power. And they said no powers. It's a what? Not a negative, it's a flip.
Is it an fraction?
It's a fractional power. Yeah. Let me review that with you real quick.
1 over 2.
Yeah, good job, Abdul. Yeah. So let's think about, do you know, like, if say you have x to the 2/3 or whatever. Yeah, let's remind, well, in fact, since you guys brought it up, let's remember negative powers, that just flips and then becomes positive. So negative powers flip things. What do fractional powers do, like 2/3? Well, the 3
The 2 comes down and jumps
swings into the hook like that. X squared. It becomes roots. Do you remember that a little bit from your algebra days? So notice the top number just stays put. The x to the 2, x to the 2, that's not going anywhere. That stays put. It's just the denominator swings into the hook. I don't know if it's any help to you all, but I used to I watch a lot of Scooby-Dooby-Doo when I was a kid, probably too much. And so I always remember the intro thing where where Scooby-Doo falls through a trap door, falls through some kind of thing, gets in the trap. So that's what I always think of. I don't know if that helps you, but if you haven't seen much Scooby-Doo, it's probably no help at all. But that 3, the denominator falls through a trap door, ends up in the hook, kind of like in the little trap area. So that's the relationship between fractional powers become roots, negative powers become fractions. Okay, so what does that mean? Well, and then think about specifically what a half would do then. Let's do the same rule. There it is. Scooby-Doo falls down into the trap. It's like that. And to realize those are both understood numbers. In other words, we could just make that square root of x. If I just write square root of x with nothing in the hook, what's understood to be there? 2. And if I show no power, what's understood to be there? 1. Those are both really understood, huh? They're the most commonly used power and root. So in other words, what this is saying is if you have the root of anything, it's that thing to the half power.
So 6 minus x.
So if I have blah, blah, blah with a root, which they're going to give us a bunch of in this section, well, 3, maybe 3 times, it'll be that blah, blah, blah to the half power. A root without anything showing anywhere is a half power, isn't it? Does that make sense? So we'll go back and do that now. We'll do that maybe 3 or 4 times in this section. Anytime we see a root, we'll go, oh, that's a half power. So let's go back. We go, okay, so this root right here, that's a half power. And now we know what we can do with powers. We just grab it, bring it down, so it's half ln 6 minus x done. We did, they said no powers, we did it, no powers. Good there. Questions I can answer on that one? One thing to watch out for, we have to have these parentheses here, don't we? Because if we don't have the parentheses, then it means only the 6 is in the natural log and the x is like, if you don't put parentheses around that, it means ln of 6 and then like the minus x is like outside of the ln. And that's not what we mean. I just want to be extra clear on that. You have to put parentheses because it's all in there. It's all been in there from the beginning. All right. So, and same thing, they're going to say summer difference, yeah. So the way they say it is they say, write as summer difference of logs, write powers as factors, write powers as factors. What factors mean? Things multiplied. That's a word for, factors or things multiplied. So, all right, so they basically want me to break this into several logs, sum and difference, added, subtracted, and no powers in the ends. So can you do that one? Can you use those properties? Give that a try. So this is dividing, right? Dividing for one log, harder job for one log, multiplying, dividing are the hard job. Harder job for one log becomes easier. What does dividing become? Subtraction, because, right, they both make things smaller, dividing and subtracting. And I do have to put parentheses around that x minus 6, to say the whole x minus 6 is in the log. Good so far? And now what? The 4... comes down to the front. 4 comes to the front. And what can I do with these guys? Well, nothing. But back when I was a student, about where you guys are at in junior college taking all these math classes, I thought, don't write that down, that's crazy. But I thought you could do that. So let me talk about that for just a minute, because I think it's important to understand why you can't do that. I used to think, well, can't you just do that? Just, isn't that the rule? It just goes to both of them. That's not true. You can't do, and you just have to leave it. It's going to stay just like that. But let me talk just for a minute about that. Remember that log is the reason that's not true, and the reason you can't do that without, like cosine. You guys had trig. Same thing, like if you had cosine of x minus y. Isn't that just cosine of x minus cosine of y? Or if you have log, of x minus y, whatever base, say 7 or whatever, Isn't that just log base 7 of x minus log base 7 of y? No, none of those are true. Those are not right. Why not? Well, first off, it's not multiplication, right? These are functions, not this doesn't mean cosine times this. Because if it was multiplication, yeah, that'd be great. That'd just be distribution. But it's not multiplication, so it's cosine of, it's function. And so is log. In other words, what it's like saying f of x minus y. It's like plugging into a function. You know what I mean? That's what I mean with all that toe struck. Now, that wouldn't have totally helped me. Back when I was where you guys are at, I would have said, well, okay, I get it, it's a function, but can't you still do that for functions? No, is the answer I needed to be shown. No, you can't. Let me show you why. I think it's worth one more minute of our time. Let me just make up a function and prove to you it's not true. How about x squared? Nice simple function. How about if I just say x squared? And I try it out. What is this side? Well, that just means plug x minus y into the function, okay? That'll be x minus y squared, right? Is that equal to, question mark, is that equal to f of x, that's just x squared, minus, and what's f of y? That means just plug y in, y squared. Are those equal? No, if you FOIL this one out, you'll get x squared minus 2xy plus y squared, right? Not equal to that one. See how it's just not true in general? You can't do that. It's just not true, right? So plugging two things subtracted in a function does not mean the same thing as distributing that function to the two. So in general, you can't do that for any function. Log, any of the sine, cosine, tangent stuff, exponential functions, any functions, you can't do that. Well, what can you do? Special properties. Only certain special properties. That's why they give us these. So anyway, long story about what you can't do. A lot of my learning of algebra was learning what I couldn't do. So I hope that's helpful for you. We just stop right there. We're done. All right. Let's. Okay, same kind of thing. They want me to make it, several logs, no powers. Can you do that one? Can you break that into several? There's no base, I guess, so it's just base 10, right? You don't need to show the 10. Just doesn't matter. No base showing. Doesn't bother us. Can you make that into several logs and then bring the power down in the end? So the x will be separate, and the x plus 3, and then this guy. Be 3 separate ones? Yeah, so 3 sides. So anything multiple, that'll be a separate log. And this x plus 3 will be a separate log. And then the other one will be subtracted. Everybody see why that third one? Because he's divided, right? He's in the denominator, so he becomes subtracted. And then last thing is to bring that power to the front. So grab this power, bring it down. So minus 13 log, and then we're done at that point. There we go. Is that okay? So anything in the numerator multiplied, right? This is x multiplied with x plus 3. Multiplied things, for 1 log, harder job for 1 log, multiplying becomes adding, easy job for 2 logs. And dividing, denominator means divided, becomes subtraction, easier job for 2 logs. Good on that? Anything I can say to help? Is that good? Tristan, questions?
Why is the last log negative?
Yeah, good. It's a good question. It's because it's down, it's divided, it's under the bar. So anything in denominator really means divide. I know it doesn't always look that way when we write these properties, but yeah, anything under a bar, anything divided becomes a subtracted log. Yeah. So we don't always think that dividing means denominator, but it does. And you want to think that, and they're going to get messier here in a few minutes, and we'll have some really ugly ones. And I'll be emphasizing that. That'll help you a lot in calculus. Just always think, basically, if you're in a denominator, you're divided. That's what it means. Any denominator item, to be in a denominator means to be divided. And to be in the numerator means to be multiplied. And that'll help us with these properties. There we go. Okay, so same kind of thing. They want you to make it several logs, no power. Several logs, no powers. So what do we do with that half power?
Would you pull it to the front? Because it's going to each part.
That's right. It's the half power for everything, so it'll become the multiplier for every log. In a minute, when I break it into several logs, it's going to go on everybody, because it was everybody's power. So let me just do one step at a time here. We good there? Now, what do we do from here? What can we do with that numerator?
Can you factor?
We can factor, yeah, let's factor. Let's bring this over here. X squared minus x minus 2. So we're looking for two numbers. You're looking for two numbers that multiply to be negative 2, add to be minus 1, right? Remember how the factorization works? Two numbers that multiply. What times what is 2? 1 times 2. And how can they add to be negative 1?
2 is negative.
Yeah, that whatever sign is in the middle has to go on the bigger number, You with me on that? The sign in the middle goes on the bigger. So negative in the middle goes on the 2, which is bigger. Minus 2 plus 1. That makes minus 1 in the middle. They multiply to be negative 2. So we factored that. So I'll put that up here. X plus 1. X minus 2. Okay, now I can do the log thing, Can you break that into several logs now? Things in the numerator are multiplied, so that'll be added logs. And things in the denominator are divided, so that'll be a subtracted log.
So would the bottom be 3 halves?
Good job. Oh, I changed that power in the bottom, didn't I? Whoops.
Oh, oops.
There we go. Nobody saw that. All right. 1/2 ln x plus 1 plus 1/2 ln x minus 2 minus, I'll keep it a half for a minute, 1/2 ln x plus 3 cubed. And then what does that 3 power do? It just comes right there, and so you get 3 halves. ln of x plus 3. And the rest are the same. Is that okay? So anything in the numerator, again, anything up top becomes added logs, positive logs. Anything in the bottom is negative because it's divided. Easier job for 2 logs, adding, subtracting. Harder when it's just 1 log, it's multiplying, dividing, huh? Good. All right. Am I going too fast? Get that down?
Do you have to put, like you have 1/2 natural log x plus 1 plus 1/2 natural log x minus 2? Do you have to put those in parentheses? Or just...
No, it's okay just as it is. Yeah, no need. They each have their own half though. But yeah, you can just leave it just as it is. Okay, so same thing. Write as several logs and no powers. Okay, can you do that one? In that numerator, make sure you treat the 3 and the x and the root as all separate, and then the bottom. So you got 4. You're gonna have 4 ln's. So everybody see that? There's 3 different. The 3 and the x and the root are all separately multiplied things. So they'll become separately added natural logs, and the one on the bottom will be subtracted. You should have 4 ln's. 4 natural logs. ln 3 plus ln x plus ln square root of, yeah, you could do it right now if you wanted, huh? Minus ln of x minus 6 to the 12. That good so far? So it's just, adding, subtracting, for easy job for lots of logs, adding, subtracting. Harder things for 1 log, multiplying, dividing, huh? And now, we can't leave power, so you know what to do, huh? So the root is a 1/2 power that we pull to the front. So we'll just say, okay, this right here is really a 1/2 power to the front, and then this 12 to the front. And so, what do we get? ln 3 plus ln x plus a 1/2 ln 1 plus 2x minus 12 ln x minus 6. There we go. It's a lot just to type that in.
Why can't you just test us on this too and knock out some of the other ones, like the box problem, and
Yeah, those are bad, huh?
unnecessary. Yeah, the cylindrical problem.
Yeah, these are better, huh?
Yeah, give us like 12 of these and take those out. Yeah.
We good? Questions on that one? All is well. All those together into 1 log. We're just kind of going back and forth, aren't we, between the different directions. So put all those together into 1 logarithm using the properties.
So they want power?
I don't know what they said. They said, that's all they said. Just 1 log. That's a minus 3 there. Okay, so what are we going to, let me help. Oh, what are you going to do with that 6 in the front?
It's going to be the power on the 7x.
Come up there and be the power. Yeah, but that root's a 1/2, huh?
Yeah.
It's going to be changed.
Excuse me. Excuse me. Yeah, so it's going to be half of 6, going to be 3.
Yeah, it's gonna be cheap.
We good with that? I'll do that kind of slowly. So it's 7x minus 3. That the root is a half power, and then the 6 comes up there also, huh? So it's going to be 3 eventually. We all good with that? To the third, like that?
Divided by. 7.
Very good, like that. So yeah, now, so from there, can you crunch them all into one log now?
When you have a negative fractional power.
Yeah, we can do.
You're gonna flip it.
Good job.
Okay.
Yes, exactly. Yeah. So putting these together, log base 7. So we have the 7x minus 3 to the third. Yeah. Now what are we going to do here with the subtract? And then that's a fraction. Subtract means divide. So should I divide by a fraction? I mean, you could. That's not false. That's true. But it's kind of hard to deal with it like that. What would be easier? Just flip it, huh? So you guys tracking with me? To divide means to multiply by the upside down, doesn't it? So it'd be easier just to leave it right on the level and multiply by the upside down. Like that. Is that good? And then the next one, that 6 comes down there. We good to there.
Times 6 or 1.
And then those 6s will cancel and we're done. But let me slow down right there for a minute. Is that making sense what I did? So, so we have several different logs. Going to make it one log. And, you know, adding, subtracting, easy job for many logs. Going to be multiplying, dividing, harder job for one log. But instead of subtraction goes with division, huh? Subtraction, instead of dividing by a fraction, multiply by the upside down. That is dividing. And then the 6's, yeah, this is 6 over 1. These cancel.
It stays up in the top and gets multiplied. Okay.
7x minus 3 to the third times x. We're
Just
done.
because it's next to the negative log doesn't mean that it gets divided.
Yeah, the negative is on this log.
Yeah.
So this log's argument will be divided, which
Right.
means upside down multiplied.
Right. Okay.
So we get there. Yeah, you might want to, just to be sure, put extra set of parentheses, just so you know that last x is in there also. I think Math Excel will take it fine without it, but just to be extra sure, that's extra clear. All that's the plugin. Is that one okay? Is that all right? Y'all see how the dividing by the fraction we multiply by the upside down? This property's making sense?
They don't want us to multiply that x in at all.
Yeah, I mean, you know, you'd have to FOIL all this out first, because remember, powers are done first. FOIL all that out, then you can multiply the x in. Yeah, we don't.
Okay, I was just saying because
So there we go. Make that into one log, a single log. Hey, Wendy. Let's make that one log.
Again, when it goes down, the 1/8, when it goes down, it like turns into an 8, doesn't it? Because you're gonna divide.
So
by-
that 1/8 will become the power.
Oh, okay.
Yeah, because numbers in the front
Right. Those are the powers.
become up there to the power, and the same thing with the 4,
So it's root. Wow.
like that. So log base a of, and then it'll be 8x squared to the 4th over 6x plus 7 to the 1/8. That good so far? And really, you might be able to leave it like that. I don't know. They probably want you to do the 4th power on that top. I'm not sure. Probably they do. So I'll do one more step. So I'm just going to do the 4th power. The 4th power up here, this one means 8 times 8 times 8 times 8. I think that's 4,096. And x to the 8th, right? The 2 and the 4 multiply. So that'll be 4,096 x to the 8th over 6x plus 7 to the 1/8, done there. that okay?
Can we go a little forward?
What's that?
Can we go a little forward or just stop it here?
Go further?
Yeah.
How so? That's it. There's nothing else we could do that I can think of.
Or you leave the x to the 8.
You can do an eighth root, put in a numerator, but there's no reason to.
Oh, yeah. I don't think they were really. There's nothing really wrong with leaving roots in the bottom. Yes.
I've seen that you multiply the 4 and the 2 on the top.
Do what's that?
You multiply the,
No, it just has to be.
Right, the 4 and the 2, right.
Yeah,
and then you multiply it out to get 4,096, but why do
They
you
can't be negative.
keep the x to the 8? Or the
well, actually, you could.
As opposed to what?
8 and then get 4,096.
Okay, so that numerator, fourth power, remember what that means? That means 4 of them, huh? 8x squared, 8x squared, 8x squared, 8x squared. Right, and so then you just multiply those 8s, add those powers.
This is, no, it's actually a really good math puzzle.
We all good? Does that make sense? So I think you can leave this 1/8 then here. It's the same thing as an eighth root. I'm 99% sure they'll take it. All right. Figure that out with our calculator. So how do you get log base root 7 of 17 on your calculator?
Sine wave.
Yeah, if you have one of them fancy ones, it'll just type it in.
Change of base.
The change of base, exactly. We're going to use the special change of base formula. Remember that? Because our calculator, we only have log base 10 and log base e called natural log. So we do, remember the top one goes top and the bottom one goes bottom. You make it 2 logs. Remember that special way? It's called change of base. Why? Because both those are log base 10s now. Before it was a log base root 7, right? This has a root 7. These guys have no bases, which means there's really an invisible 10 there, huh? See how we changed the base? Made it 2 logs. So then just hit the button. So I don't know what that is. Whatever it is, that's your answer.
17 over log root 7.
I'm getting 2.911.
911.
911, 967.
Yeah. 2.912. 2.912.
Yeah, however far they want you to round it.
2.912. That's what I got too.
Technicalities.
We good?
There's spelling numbers.
All is well. I want you to graph this one on your graphing calculator. So y equals log base x minus 7 of x plus 10. So go ahead and put that into y1 in your graphing calculator. They're telling you the window. Here's the x window. Here's the y window. So put that into your calculator in y1 and graph it.
Too hard.
Wait, how do you make it go as like the power thing?
You have to use the calculator if you have a variable in both the base and the power, not power, but the.
Yeah, that would be.
How do you put it in the bottom?
Yeah, so that's exactly what I want you to see. Do y'all see that? How are you going to put in a base of x minus 7?
You put it out in front.
Got to use the special log thing, right? I want you to see that. Yeah, because remember, whenever the base is weird, it's not 10 or e, we have to make it into 2 logs, right? So this is one of these cases. So you've got to go y1, let the top go top, so that one will come first actually, won't it? X plus 10, see what I mean? Divided by log
And
x
it's gotta
minus
be
7.
in parentheses, doesn't it?
Mm-hmm,
Okay.
it does.
Doesn't the division have to be in parentheses?
That's only if there's more than one item. We only have 1 log at the top, 1 log at the bottom. It's all good.
I always just do it just in case.
Is that good?
I have a quick question.
Yeah.
Like, you see how it was in the bottom, it was the base, but when you went to go divide it, you just moved it like.
To the right?
Yeah.
Yeah, because
Does that
it-
make a difference? What? Like, because I'm getting kind of confused.
Yeah, no, yeah. Because remember what we learned. Remember what the, let me go to a fresh screen. Remember what, how do you do, what about the one we just did? Yeah, how did we do this one? Look at this one. What did we do? This one, the one that's a little higher up, I say top goes top, and the one, right, he goes up here, and the lower one goes lower, right? Top goes top, lower goes lower. So if you were to write this out as a dividing, Who would have to come first?
What's the window?
This guy. Right? Log 17 over log root 7. This is sideways division. This is vertical division. They're saying the same thing. So do you see what I mean? Is everybody seeing that? The one that's higher up has to come first because he's the top. That's what I did here. The one that's higher up has to come first.
Yeah, no, I got that. I just didn't, I don't know why'd you move it from the base there? Isn't it, when it's a base, it's a little lower? Or?
This x minus 7 is lowered down?
Yeah.
Right, so what's your question, Ez?
Why is it to the side now? Why is it not lowered? Why is it not?
Oh, because I have no way to type that into my calculator.
So it's not,
It looks like
there's
your
no
thing is
difference.
Yeah, there's no, if there was a way, well, and some of the calculators have a fancy way.
Yours is wrong.
But if there was a way to type it in just like this, I totally would. But that one you're holding right there doesn't do it, I don't think. And most of them don't. Yeah, is everybody making sense of this? The reason I'm changing it is because the calculator simply can't handle it straight.
Oh, okay.
Most of them,
So
anyway.
it's freaking out? Is that what it's doing? Is that what it looks
There's
like?
no way to put in a different base than 10 or E on most calculators. There's a couple special ones that do some fancy stuff. But most calculators, there's no way to put in a base other than 10 or E. Does that make sense? I can't put in a base of x minus 7.
Mine's not activated.
So you have to do it this way. So yeah, so then you just graph it. Isn't it B? I think it's that one. When you graph it, make the window and everything.
But you have to make sure it's not activated. You have to like go back.
Okay. And then they say write
I tried this one too. I tried the other one.
write y
You have to take off the highlighter.
as a function of x.
Oh. Okay.
For them to, when they say write y as a function of x, they're saying they want us to get y all alone, all by itself.
Divide by ln?
Yeah, can we just divide by the ln?
No.
Because it's not multiplied. Yeah, so we can't do that. Yeah, what do? We do the e, huh? You know how to get rid of an ln, right? Any log is you just power by the same base, huh? How are we doing?
Oh, I have to rethink.
We all good? I'm looking out at you. I'm not seeing any knowing looks. Just making sense? So the way to get rid of it, so let me slow it down a little bit again. So we've got this big old messy thing here. And they're saying, please get y alone. Please get y all by itself. And to get y all by itself, I somehow have to get that log out of there, don't I?
So you're gonna
And what will get rid of any log?
divide it by ln.
We power the same base, huh? So yeah, and what is the base? Well, there's an invisible, understood little tiny e there. So I just e this side, big old E, and E that side. Only one. Only one E on the left, only one E on the right, right? Equal treatment. We can't be doing more E's or anything, right? One E on the left, one E on the right. Let's be excuse me, really careful here with the properties. Here we're going to learn some special rules about powers and how they work. So now what happens on the left side? Y is alone. These cancel, right? When the base of the log and the base of the power match, they just cancel. We know that quite well. So that would be y equals now. Here comes the other side. This is where probably you'll violate a rule you already know, but you'll break the rule you already know because it's just tempting to do so.
Well, if you only have one E, then it really can't touch past the plus sign.
I did that
'cause
mistake.
Pluses and minuses.
Can it? Yeah, can it just cancel those two LNs? Well, no, actually it can only cancel one at a time. So, okay, but can't I just go like this though? Can't I just say, okay, it's like that and it'll cancel that one and cancel that one? Almost. That's so close to the truth, but not quite right. What it is I'm forgetting, this actually has to be times in the middle. Now, why does that have to be times? That kind of looks like where'd the times come from? It's adding up there. Well, remember the power rules? Let me come over here on the side. You know this rule, actually. It just looks weird in this setting. Remember like x squared times x to the third? Remember when you have same bases multiplied? What do you do with the powers? Add them, huh? Two of the same exact base multiplied. You just do one of those bases, add the powers, huh? Well, that's what I just did. Look at this. Two of the same bases multiplied is one of those bases, powers added.
17x.
That's true, isn't it? See how it's that simple rule you know about, but, messy situation? That's what I mean when I say calculus is all about algebra. I mean it's hard algebra, like that. That's a rule you know. But you don't know it probably yet so well, so deeply, that you recognize it even in really ugly situations. That's what you want. That's what it takes to make it in calculus, is more and more deep comfort with these algebra rules. So you just look at that and you go, no, that's times. Same base as times, powers added. So that's a deep, solid knowledge of those algebra rules.
Is it y equals 17x plus c?
So now we're good. Yeah, now boom, boom, totally. Y is 17x times c.
Oh,
Done.
times,
Right, because that times is still in the middle.
yeah,
He hasn't gone anywhere.
because I thought it's still.
So it doesn't end up plus in the middle, right? Because our knee jerk would have been to cancel both those and leave a plus in the middle, huh?
Right.
But it actually becomes a times because that's the rule. Same base as multiplied is powers added. Is that good? See that? So that's what we're doing here, is getting you so you'll be ready to go for calculus. Because that's the kind of thing they do all the time in calculus. All right, and now what they're going to do is they're going to remove one of these LNs. They're going to come over and go, now what if we take one off? Now they don't both have LNs, and the E doesn't cancel one of them, and how's that going to work? Let's see. So that would be number 29. No, actually. Okay, same kind of thing. They want you to get Y alone. So how do we get Y alone there?
Well, first you gotta base 10
Base.
it. Oh, yeah,
Maybe.
sorry,
Yeah, do the base E thing for sure.
but that only takes care of that. And that.
So E on this side, E on that side. All right, and now make that two E's on the right side. So the left side, these just cancel. No big surprise there. On the right side, make it two different E's. Multiplied, huh? Same bases multiplied is one of those bases powers added. See how that's the same rule? Is that good there? And now, these guys cancel. What's the other one do? The other one just stays. E to the minus 3x, can't do anything with that. Times C. This just drops down, right? When the E and the LN cancel, the C just drops down to regular level. It doesn't float up there in the power zone when there's no base for it anymore. The base has been dropped out, canceled out. So it just drops down to regular level. Just add the 4. So E to the minus 3x times C plus 4. And we're done. There it is. Is that okay?
Yeah.
You good with that?